Section 8.6 is comparing our linear, exponential, and quadratic functions. For your learning target, you will be able to choose a function to model data. You will be able to write a function to model data, and you will be able to compare functions using average rate of change. So average rate of change is kind of like your slope. Okay, so you're looking at the change in y's over the change in x. Slope is specific to your linear function. So our other functions, we calculate the average rate of change, but the formula is still the same. So over here in your core concepts, you have your linear function and the standard form of the equation shown, your exponential and that equation, and quadratic and that equation. So keep this in mind as we're working through this section. For example 1, we're using graphs to identify functions. So we need to start by plotting these points. And once we plot these points, then you're going to determine if this is linear, exponential, or quadratic. So first we're plotting 8, 4. Four, 0, 0, -4, -2, -6, and -4, -8. So looking at these points, this kind of looks like a linear pattern. So this is going to be a linear function. So we're going to do the same thing over here. -3, 6. -2, 1. 0, -3, 2, 1, and 3, 6. And now having these points, this is following like a parabolic shape. So this one's going to be a quadratic. Okay, example 2 is using differences or ratios to identify functions. So we want to tell whether the table represents a linear, exponential, or quadratic functions. So remember, in a linear function, you are adding or subtracting the same amount each time. In an exponential, you're multiplying or dividing by the same amount each time. And in a quadratic function, your second differences are going to be the same. So if we look at this table here, I'm going 11, 5, 3, 5, 11. So I'm not multiplying by the same amount each time or dividing, and I'm not adding or subtracting by the same amount each time. So we're going to check for our second differences. So first, that means we're going to look at how we're getting from each number to the next in this table. So to get from 11 to 5, I'm subtracting 6. To get from 5 to 3, I'm subtracting 2. To get from 3 to 5, I'm adding 2. And to get from 5 to 11, I'm adding 6. So now we're going to look at our second differences, meaning how are we getting from each of these first differences to the next. So to get from -6 to -2, I add 4. To get from -2 to +2, I add 4. And to get from +2 to +6, I add 4. So since all of these second differences are the same, that means this is going to be a quadratic function. Okay, again, this is still example 2. So we're looking at how we're getting from one number to the next in this table. So from 6 to 8, I'm adding 2. From 8 to 10, I'm adding 2. From 10 to 12, I'm adding 2. And 12 to 14, again, I'm adding 2. So since we're adding 2 each time, this function is linear. And another one for example 2. So again, we're looking at what pattern we're using to get from one number to the next. So if I multiply 0.5 times 6, I'm going to get 3. 3 times 6 is 18. 18 times 6 is 108. 108 times 6 is 648. So since we're multiplying by the same amount each time, this function is an exponential. For example 3, we're writing a function to model data. So it wants us to tell if this represents a linear, exponential, or quadratic function, and then write the function. So first we're going to look at how we're getting from each number to the next. So -3 plus 2 gives me -1. -1 plus 2 is 1. 1 plus 2 is 3. 3 plus 2 is 5. So this is a linear function. So now to write the equation, we have to think back to writing our linear functions when we have a table. So if you look at this point right here, this tells us some important information. Because our x value is 0 and we have a y value, this is your y-intercept or your b value. Our pattern of adding 2 is also important to us because this is actually our slope or our m value. So if we're looking at y equals mx plus b, we're going to plug in that slope for the m value and the y-intercept for the b value. So our equation here is y equals 2x plus 1.